All right. Welcome, everyone. My name is Anna Sackman. I'm the Data Services Librarian at UC Berkeley, and I'd like to welcome you tonight to the last workshop in our Data Analysis Workshop series. I'm going to share my screen really quickly. All right, so this is the fourth workshop in our series on Introduction to Data Analysis with Python and SQL for Data Science. And tonight we have one instructor and two helpers. I'll go ahead and make this bigger. Hopefully everybody can see this. So I'm going to go ahead and let our helpers and our instructor introduce themselves. Ja, why don't you go ahead?
Hello, nice to meet you. I am Ja. I'm a senior studying data science in econ, and I will be the instructor for today's session.
Great, thank you. And Mahati, go ahead.
Yeah, sure. Hi, everyone. I'm Mahati. I'm a junior double majoring in computer science and data science, and I'm going to be a helper today. So if you have any questions in the chat, feel free to ask.
Thank you. And Akshay.
Hi, everyone. I'm a double major studying environmental science and data science. I'm a consultant, and I will also be helping in the chat.
Great, thank you. Okay, so as you just heard our helpers say, there are a couple of ways to get help tonight. You can go ahead and put your question in the chat box and one of our two helpers will respond, or you can raise a hand and unmute yourself. This might be particularly helpful when we're doing some exercises, or you can select a reaction from the participant menu if we're going too quickly, or you need to get our attention for any reason. Please go ahead and utilize that. And tonight we won't be using breakout rooms, but if you really get stuck, then one of our two helpers can kind of pull you off to the side in a breakout room to get you back on track. So tonight we'll be working out of a GitHub repository. All of tonight's materials are located there. And I will put this link in chat in just a few minutes. And like I said earlier, today's workshop will be recorded and posted on the library's YouTube channel. And you'll all receive a link in a couple of days once that is up and ready to go. So I'm really excited about tonight's workshop, and I hope you all get what you came here for. And at this point, I'm going to turn it over to Ja.
Hello, yeah, I am just gonna share my screen. Can everyone see this? Okay, so today's workshop will be on SQL. And then before we begin, I want you to complete the survey, which I will drop in the chat below. Okay, yeah, please just fill it when you have the time to. Okay, so I'm Ja. I'm a senior studying data science econ. Then I will be graduating in the spring. So this slide basically just tells you the SQL basics. So today in our exercises, we will mainly be working with commands such as select, from, where, group by, having, order by, and limit. So basically what the select keyword does is it chooses the columns from each table, right? So in every table, in every data set, there are columns, and you will just if you want to choose a column, then you will just use the select function. And then the from basically just chooses which table name you are trying to choose the data from. And then so where is a function to just filter out the rows. And then group by basically just groups all the data by whatever you want to group them by. And then having happens after group by because it filters out the groups. So here you may have heard me say that where is a filter function for rows. So then you might be asking, when can I use where? Where can I use having? So having happens before group by. Sorry, where happens before group by, and having happens after group by. This is because where is a function to filter the rows, and then having is a function to filter the groups. And because group by groups all the rows together. If you want to filter the rows, you have to filter them before you group them. And if you want to filter the groups, you have to filter them after you group them. And then order by is a function just like to order them in ascending or descending order. By ascending order, it means like smallest to biggest, right? If they ask you to have to display a table with the 5 smallest numbers, then you will do them order by in ascending order. If they ask you to do them by greatest to smallest values, right, then you will do them in descending order. And then limit just shows you how many number of rows you want to output in the table. So basically, for example, right, if they say output the top 10 results, right, then you would limit them by 10. And then so for select and from, right, this is a mandatory part of every SQL statement, because like this is like apparently like essentially this is like the most important part of like any SQL statement, because like in every SQL statement you need to select columns and you need to like specify which tables you're selecting from. So for example, we are going to be selecting column A and column B from tables 1 and 2. So here are like four statements, right? So this, like the first statement basically says like select star from table. And then now you may be wondering, right, what does this like asterisk, what does the star mean? So basically once you do the select star, select asterisk, it means you're selecting all the columns from the table. In this case, this table name is just called table. And then the second statement, this is selecting the weight from the table. And then you're basically selecting the weight and height from the table. And then for the third function, you're selecting the maximum income from the table called salaries table. And then for the last one, you're just like selecting the result of like speed divided by time from the physics table. And then here you may see this colon, right? What does this mean? So in every SQL statement, it's a good practice to just like end every statement in this colon, because then it tells the computer, it tells the Jupyter notebook, it tells like data hub, it tells like whichever terminal you're running in, that the statement is done. Like, so for example, right, if you don't put a colon at the end, then your computer is basically not going to know that the statement's done. Then so where, the where clause allows us to specify certain constraints for the return data. And then, so basically, like I said before, where happens before group by, and it's because we want to filter out the rows. And then we can also use Boolean operators such as greater than, less than, greater than or equal to, less than or equals to, as such. And then we can also use conditions such as and or not. For example, if we look at this, we're selecting all the columns from table 1, where column name, and then this bool operator just means like, for example, in the place of like this bool operator, you can just say where column name is like, for like equals to column value or something, right? Or it's like greater than column value. Or you can just say, just like play around with it, and then just in the place of bool operator, just like insert whatever the question's asking. So for example, if the question's asking you to output the results of like the greatest, like, for example, if in a data set, if there are 2 columns such as income and height, and they ask you to output values where the income is always greater than the height, then you will just like put the values such as like where income is greater than the height. And then so we will also be working with a distinct, count, order by, and limit, and this slide just like shows us like, so for distinct, basically, as you can know, like in English, distinct just like means like distinct values, right? Like different values, like values that are not repetitive. So sometimes in data sets, there can be data that are repeated. So if you want like unique values, then you just use distinct in front. And then order by, you can do it in ascending order or descending order. And then limit just like shows you like if they ask for 10 top values, then you just like limit by 10. If they only ask for 5 values, then you limit by 5. And then by default, the order by works in ascending order. And for example, what I mean is like if we look at this, right, we're selecting all the columns from table 1 where we are ordering by column 1 in descending order and column B in ascending order, right? So what do I mean by default, right? So for example, if I just like write this, if this is the code, then we are not specifying whether we are ordering column A by ascending order or descending order. But because we didn't write anything, SQL is just going to assume that it is in ascending order, because order by how it works is it is by default always in ascending order. So it's like if they ask for ascending order, it's fine if you write ASC, or it's also fine if you don't write ASC. But if they ask you in descending order, you must write DSC. And then limit, just like here, just like specifies the limited number of rows in the result to be returned. So like I said before, like limit 10 will return the first 10 rows, and limit 5 in this case will return the first 5 rows. And limit 7 will return the first 7 rows. And then now I will be this slide will be talking about aggregations. So far we've only worked with data from the existing rows in the table. But like now, right, by aggregations, there's like functions such as count, sum, average, min, max, right? So in this case, these aggregations only work on columns. What I mean by this is like, if you look at this, like this table set, like the table data set, right? You can see student ID, you can see name column, you can see age column, right? We are basically aggregating the age column on the max function. So by writing select max of age, we are like trying to output a table where only the max age will be outputted. So in this case, because like they're tied, right, only bcon and dcon will be outputted. Like the rows containing bcon and dcon, because their H18 is like the max in this table. And then so now I will be talking about group by and having. So group by basically just like groups all the rows. And after you write the group by function, you cannot use where anymore, because where is a function to filter by rows. And group by just like puts all the data set into groups. So if you want to filter after you group by stuff, you have to use having. So here, let's look at the group by function again. So here we are selecting the department ID column without aggregating it, but we cannot select any other columns without applying an aggregate function, such as like max, min, or stuff, right? So here, if we look at this, we are selecting the department ID column, this column, and the average salary column, right? So because we are only selecting these like department ID and salary column from the original employee table, right? We are like the final table would not have the employee ID and e-name in their results as such, because we set average, because we aggregated the salary column on average, the output will be in like average of the salary column that is grouped by department ID. So what this means is, if you look at this, right, if you look at the department ID originally, there's like groups 1, 2, and 3, right? So we are first like grouping them into groups 1, 2, and 3, and then we're taking the average of these groups. So for instance here, right, group 1, it has a value of 6,000, and then because we're finding the average, right, 6,000 divided by 2 rows is like 6,000 divided by 2 is 3,000. As such, for group 2, there's a value of 4,000 plus 5,000, which is 9,000, plus 3,000, 12,000, divided by 3 is 4,000. And then that's how you get like 4,250, 4,250 for department ID 3. But what if, for example, right, in this case, this like aggregate function for average work because salary is like in numbers, right? And average function obviously only works on numbers. But what if we wrote something like, what if we tried to find the average of the e-name, right? E-name, obviously, as you see, it's not a number. It's like, it's in alphabet, right? It's in characters. And you cannot find the average of characters, right? you can only find the average of numbers, right? So in this case, if you try to find the average of the e-name column, you will like have an error. It will output an error, or it will output like a column of zeros. And now we'll talk about having. The having function is similar to where, but where filters the rows and happens before group by. Having filters groups as such. Having happens after group by. So here, what if we use this query, right? What if we are selecting department ID? We're aggregating the salary column on the average function. We're selecting it from the employee table. We are grouping by the department ID. It's like our original table, right? And then we want these like groups, right? We want these groups that have values greater than 3,000. But what if we change this to like 4,000, right? As like in this case, like does anyone in the breakout room want to answer this? What if we change this to 4,000? What would the final table be? Like, feel free to unmute yourself. Right, so yeah, basically, if we change this to like average of salary greater than 4,000, right? What happens is, because we only want these like group average salaries greater than 4,000, like this department ID one, this first row would disappear. The second row will also disappear. So our final answer would only be like it will only be this row. It will be department ID average salary of like department ID 3 and average salary of 4,250. Let's go to another slide. Right, so here it's just like showing, right? Because in this case, they are asking for average salary greater than 3,000. So in this case, the first row gets deleted. But if we do average salary greater than 4,000, the first and second row gets deleted. And now let's talk about SQL joins. So in SQL, there are 4 types of joins: inner join, left join, right join, and then the full join, also known as the outer join. So what inner join, like here, like these are like visuals, right? You can like come back to this later, but basically inner join, and this is like how the data sets will work. Like this is like the left table and this is the right table. And then so here in inner join, right? You're selecting every column from table 1, inner join on table 2, on table 1, on like, so basically in each join function, in order to join 2 tables, you must have the same column name and the same data type in each of the 2 tables. So in this case, like table 1 has the same column as the table 2. So in this case, we can just say, right, because we are selecting every column from table 1, and we're inner joining them on table 2, right? Let's for instance say we want to select the column like max or something, right? And then we can say the column name is max. It has to be table 1.max equals to table 2.max. You have to make sure both tables contain the same column name. And then so here, like I'll show like an example of what happens to the results. So here we are selecting the first name, the last name, the order date, and the order amount from customer C. So from what this means is like we're selecting these 4 columns from the table customers. And we are going to name this table as C. Just like we are like only naming this as customer C, just so that it's like easier for us to like work on later. It's also fine if you just like delete the C, right? For in this case, if you delete the C, then you have to put this as customer star customer ID. So okay, so essentially what we're doing is like we're joining the customers table inner join on the orders table, and we will be naming the orders table as O, and then we will be joining them on the customer ID. In like these 2 tables, they're the customer ID columns, and then the final result is this table basically. And then so this is like how like left join, it's similar to inner join, but how left join works is like you are appending information about orders to our customer table, right? Regardless of whether customer placed an order or not, we would use the left join. So we are selecting like the same columns as before: first name, last name, order date, order amount from the customer's table, left join on orders, where the customer ID from the customer table is the same to the customer ID from the order table, and then where the order date is null. So we don't want like null order dates basically. These are just like examples. Like when you like work on the worksheet or the examples, are like it'll make much more sense. And then similar thing for right join. Instead of like aggregating them on the left end, the table, the data set, they'll aggregate on the right end of the table basically. So here it's a mirror version of the left join and allows to get a list of all orders appended with customer information. So as like before, we are selecting the first name, we are also selecting the last name, and we're also selecting the order date, the order amount from customer's table named C. We'll be right joining orders O on customer, like on the customer column, customer ID column from the customer C table, and customer ID column from the order O table. And this is basically the result you get. So like for outer join, this is like the most frequently used join type of join in SQL, because it just like appends everything together. So you will be surprised to find out that the results might contain some null, and I will explain this. So what happens, like, so for instance, right, if we do outer join, it just like it's for a list of all records from both tables. Like, so if you want like everything from both tables, you can use an outer join. In this case, there's like null because there's like some stuff from table customers that aren't included in table orders. As such, because we're using outer join, we're not filtering out anything. We're like just like going to display everything and like have the empty values as we're going to display them as null. So this is like what happens when you like use outer join. If a value for a data set doesn't exist, then you just like write them as null. And then we will also be working with the like operator. So this is used in the where clause. So the where clause basically filters out rows. So, and because it's a type of filter method, the like operator you can consider as a filter method too, because it's like using the where clause to search for a specified pattern in a column. So basically, if you use the percentage in the code, then it represents 0, 1, or multiple characters. If you use an underscore, it represents a single character. And then, so you might be wondering, right? What do you mean by if you use a percent sign, it only represents 0, 1, or multiple characters? If you use an underscore, how does it represent a single character, right? I will be explaining those. Like, so by using this percent sign, if you write, for instance, right? So let's say this is your where statement. You're writing like where this names column, like a percent. So here, like you see, as you see, this percent sign is at the end, right? So this basically means any number of characters after a. This where statement will output any result that starts with the letter A, because you wrote A in the percent sign. What if you use the percent sign in front of the letter A? Then it will output any character that ends with the letter A. What if you use the percent sign before and after the letter A? Then it will only output the results with the letter A in it. So what about the underscore, right? How does underscore work? So in this case, like this is your where statement. So where the names column, like a underscore percent sign. So this will output the results where A is the first character followed by at least 2 more characters. And then these substrings will also be useful for like future references. Like for basically in SQL, the substring function works is like it extracts characters from a string. So for instance, like this function, right? If you write substring of like this string, so you just like put the string in the substring function, and then you write how many characters you want to extract basically and the length of it, like where you want to extract. Like for instance, right? So let's say you have this like SQL substring, right? So because you want to be, sorry, let me make it more clear. In this case, right? Here you want this to be a string, right? Because it's a string, it always has to be in quotes. How this like works is like every string needs to end in quote and start in quote, in quotation marks, I mean. So let's say our thing is hello world, right? And then this is like the string we want, and then we want to start from the first character, and we want to make sure the length is 3. And so the output in this case would be output will be HEL, because like first, second, and third. What if we want to start from the third character and end in like the fourth, right? Or let's say like fourth would be 1, like the first character in this case is H, the second character is E, third character is L, and then the fourth character is L, so the output will just be L. Yeah.
Ja, there's a question in the chat if you can take a look.
Yeah, you can use regex, but for like it might just like be a little more complicated than using like, but like there's like in SQL, like there's like multiple approaches to answer just like these questions. So if you're more comfortable with regex, I would say like go for it. And then so what you have to know is like if you're familiar with Python, you know Python indexes start at 0, but for SQL indexes start at 1. So what this means is every, like in this case, right? It's not 0, 1, 2, it's 1, 2, 3. So the first character is like always index 1, not index 0. In this slide, we'll be talking about views. So this create view creates a virtual table that you can access in your query. And then, so you're wondering, right? How's it helpful, right? It's like, it's helpful when you want to create a new table that isn't in your database. And then you can basically just like use this database to just like join with another existing table that you already have. And then, but like, it's like very similar syntax. So instead of like, so here, how this works is like you're just like creating a virtual table, right? So you just like create view as the function, and then this is like the name of the view, so view name, and then you're like selecting these columns from this table, and then you're writing your where condition, and then once you have this, you can just like join this back with another existing table. And then so subqueries, right? A subquery is a SQL state. It's a SQL query nested inside a larger query, and then it's usually in the form of and or where, and it's usually in the form of and, like it's usually in the from and where clauses. So the from clause is just like a subquery where the output will be another table. So for instance, right, we are like from this, like what this from means is like from, and then we're like selecting these stuff, and then so this, you only work with this when the data sets or just like the question gets like so complicated. So in this case, like I will break it down. So let's look inside these like quotation first, right? So you're selecting column X from this table name, whereas in this predicate X, right? This is like your where statement. So you are selecting this table, and then you're like selecting from within this table, and then you're naming it as table 2 and table 1. And then so this where clause, how it works is that it's a subquery where the output is a value. So it's like I said before, right? Where it's like the filter thing. So you're basically doing where max length is equals to like you're like selecting the max duration from the table fields. And so we will now be working on the workshop. Can you see? Yeah. So how this workshop works is like if you want to run a cell, you have to go to like shift enter, shift return, or shift enter. So that's how you run the cells. Like it's like important to run these cells to set up the notebook. So this is because like this is the only way SQL will work. So I'm going to press shift enter, and then it will just like import the libraries, the packages onto my computer. And so after that, we will now be installing our data set. In this case, we are going to be working with a CSV file called movie metadata. So this is a movies data set that we'll be playing around with.
John,
So
let's
what this
let's pause for just a minute and make sure everyone can open their notebooks.
Yeah.
And let us know in the chat if there are any issues. Maybe take about 15 seconds. All right, go ahead. Thank you.
Okay, so here we are going to be working with this movie metadata CSV file, and then we are naming this as the movies variable. So now I'm going to press shift enter. And so what this movies.head means is just like display some of the first few rows in the movies data set. And so here because this is like a pretty big table, right? You want to know what columns are included. So to find all the columns name, we can run movies.column. So by running this, we get like columns such as color, director name, critic for reviews as such, and then which will be very helpful when we work with questions below. And then the to_SQL method writes records stored in a data frame to a SQL database. So when I press shift return, right, it just like it says like there's like 5,043 records stored. So I will be showing an example. So what do you think these example SQL statements will output? Note that when we run SQL queries in this notebook, they must be written in the format engine.execute, this one, right? Well, like to run correctly. Additionally, the result will also be a list. So question 1.1, this is an example. Like this query uses distinct and where. So here we are selecting actor 2 name column. So let's see actor 2 name column. So this is the column we will be selecting, like this column. This is the column we'll be selecting. And then because like I said before, right, in the slides, distinct just displays all the distinct rows, like the values are not the same. So we will be selecting distinct actor 2 names from the table movies where the IMDb score is greater than 8.5. And we're like running this just like to display the table. So in this case, we will see like these 5 actor names are like the distinct values in actor 2 name column. And so the other examples, like this query uses like, so in this case, we are selecting movie title from the table of movies where the column genre includes the word thriller. And because like in this case, you might be wondering, right, why is the table, like why is the output in movies table and not in genres, right? This is because we are selecting movie title. What if we also select the genres column? In this case, this would like also be, so as you see, right, this like I said before, right, if there's a percentage sign in front and at the end, this means they will output any, like from the genres column, it will output any of like these rows where the word thriller is included. So in this case, as you can see, thrillers included, thriller, 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 thriller. What if I do this as action, right? The output will change. So then in this case, like action, 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 action. And then this next example uses group by, order by, and limit. So in this case, we are selecting the column country, and we are also selecting the column duration, but we are going to be aggregating this duration column by the average function. And then we'll be selecting this from the movies table, and then we will be grouping them by the country, and then we'll be ordering them by the average duration in descending order. And then we will only want to display the 10 top rows if there's 10. But in this case, there's not 10 rows, so there is only like 5. But like, let's see, what if we selected another column instead of country, right? What if we selected director name instead of country, right? What if we selected director name on the average duration, and then we group by director? In this case, it's erroring. Let's see why this errors. And then this is because like what they're saying is like there's no such column as director. So then you have to like think, right? In this case, when this happens, then you go back to your original data set and see why is this erroring. In this case, this is erroring because there is no column with the name director. So if you look here, right, there is no column with the name director. There's only director name. So you have to like make sure you are using the same column names to make sure they don't error. So now I'm like going to fix this, and I'm going to press Shift Return again and see what it outputs. Oh, look, it's not erroring anymore. So in this case, we are, just like grouping them by director name instead of country at this time. And then now it's your turn to work on this. I will give you 3 minutes to work on this. Please, yeah. Let me know if you have any questions. Work on this. So what this question basically says, okay, let's read the question first. So in SQL, it's like always like good to read the questions because the question basically tells you the answer. So here in this case, it's say show the titles of all the movies that have a content rating of R and durations under 100. So in this case, you already know this is a type of filter, right? So then in this case, you have to use where because you only want to show the movies that have content rating R and durations under 100, right? In this case, let's and then here it says like remember that you can call movies.columns to refer back to all the column names in the data frame. So in this case, it's like very tedious work to just like be going up and down the notebook just like to see the column names, right? So what we can do is like we can just like put the plus sign here. If you see it here, there's this plus sign, you press on it, and then there will be a new place to like put your code. And what you have to do is you just have to write movies.column, and then you press Shift Enter, and then you'll get, sorry, it has to be movie.columns. So in this case, you will just like get all the column names in the table movies. So let's see, we want the columns like content rating and durations, right? So we want to be, but be careful though, what do you want to show? You want to show the titles, right? So in this case, let's see which one is the titles thing. So here, let's look, movie title, right? So you want to be selecting movie title column from the movies table, and then where the content rating, right? So let's see content rating here, where content rating is equals to R, and durations is less than, it's 100. So let's run this. And this is like the movie titles. These are the movies with content rating R and durations less than 100. Okay, so let's work on this question like 2.2. I will give you another 3 minutes. Let's come back at 7:55. All right, let's come back to this question 2.2. So it says like show the titles and duration of all the movies that have action as a genre. So in this case, we want to show the titles, right? And the durations as well. So in this case, we have to select the columns movie title, duration column from the table movies where they're saying like where they have action as a genre, right? Where genres column has action in it. So in this case, like the easiest way to would be just like to have the word action and then to have the percentage signs like right in front and right at the end. So a percentage, and let's see how it goes. And then so these are the movie titles with the duration of with the durations that where its genre includes the word action. Okay, so let's work on this next question. I will give you guys 3 minutes. Let's come back like 7:59. Okay, so let's see this next question. It says like show the directors that earn the top 5 largest total gross sum. So here you have to be like careful. Like I said before, like if you read the question carefully, it says like that earn the top 5, right? Then that means like we have to use something called limit, right? Because they're only asking for top 5. And then it says like total, like largest total gross sum. Right? Largest, we know we have to do them in descending order. So we also have to like use the order by. And then it says like total gross sum. So we know we have to aggregate this on sum. So let's see how we should work on this. So we will be selecting the director name. We will also be selecting the gross column, but because it says like total gross sum, we will be using the sum, we'll be aggregating on the sum function. And then we will be writing this as sum. And then from the table movies, we'll be grouping them by director name because like obviously it doesn't mean that one director can only produce one movie. Each director can produce like many movies, right? So that's why we will be grouping them by like the director names, just like to get like a clear idea of like how much each director earns, like the largest gross sum. And then we'll be ordering them by this like sum of gross in descending order, and then we'll write limit of 5. But when we run this, this is saying it's erroring. Let's see. This is erroring because here the director name is like wrong. So we have to make sure we spelled it correctly. Okay, let's try looking at the columns again and make sure we have the columns. Okay, so here, right, so what's happening here is like when you don't run a terminal for so long, when you don't run this notebook for so long, these can like start erroring. But in this case, I am just like spelling this incorrectly. So here, if we take director name, and it's like this is the answer you'll get. This is the table you get. So previously, my error was that I only did group instead of group by. So that's why it errored. So you need to make sure you get the group by, order by, everything correctly before you run it. And you also need to make sure you're getting the column names correctly. And let's work on this next question. And then we will come back at 8:05. Let me know if you have any questions. So let's come to this question 2.4. It says like show the 5 countries that have the highest average IMDb scores. So in this case, because they're only asking for 5 countries, right? We need limit. We know we're gonna use limit, and then they said highest average IMDb scores. We know we are going to group by something, and then average on the IMDb score. So in this case, we will be selecting the country column with, and then we'll be aggregating the IMDb scores on average, and then we'll just like name this as average IMDb. And then we'll be selecting these columns from the table movies. We're grouping them by country. And we'll order them in by average IMDb in descending order. And we'll be limiting by, which is showing wrong because I did not get the right column name. Okay, let's see the column names. So we want the IMDb scores. In this case, so here IMDb as average IMDb. Okay, so then now it should work. Now this is like the table it should output. Always like make sure when you are like erroring, right? Let's have this as an error, just like so that I can show you how to debug or just like, look at your error. So in this case, like something good about this is that it just like shows you where you're getting your error, right? In this case, like, if you just like scroll down to the end, you're seeing like there's an error, like no such column as average IMDb, right? So in this case, you should like look back at your code and be like, this average IMDb is what I wrote, right? So then you should write, it's supposed to be AVG underscore IMDb. But here I wrote AVG underscore IMBD. So this is where the error is. And then if you change this error, it should work. Yeah. So now let's run this cell and let's take 5 minutes. Let's take 3 minutes to work on this. Next question. I hope you. Let's work on this question. I hope you had enough time to work on it. So let's read the question. So it says like, of the movies that have an IMDb score lower than 5, find the number of English movies made in the US or UK. There should be 412 total. So in this case, right, let's see, we will be selecting count of movie titles because this is like, they want the total number of like movies. So this is why we're using count. From the movies table, where IMDb score is lower than 5. And then they want the English movies, right? And so you write and language is equals to English. And you also want them to be made in the US or UK. In this case, I write country equals to, let's see, USA or country equals to UK. And let's run this and it's showing it's an error. And then here, let's debug this. And then it's saying there's no such column as movie titles. So now we have to make sure why it's, let's look at the thing and then let's look at the columns. And then it's because the column is called movie title and not movie title. And then so because like we're running out of time, you guys should just like work on the last 2-3 columns at home, and then the solutions are posted on the GitHub as well. So you can also like email me. My email is, I will drop it down in the chat. Like just like feel free to email me like any questions. So yeah, thank you for coming today. Yeah, does anyone have like any questions?
All right, while you're thinking about questions, I'm popping another link into the chat for our post-workshop survey. Let us know what you thought, if it was helpful. And we have just a few minutes for questions.
So